Hello, welcome back to DSA design series. So today in this video, we are going to solve the level up problem of the previous problem which we did, the range sum query 1D. So today we are going to solve the range sum query 2D immutable. So if you have not watched the previous problem, please watch it first. Otherwise, you won't be able to understand this question. Okay. So here we have to complete this class, num matrix class. We have a constructor function which will initialize an object, and that object will have a matrix, a 2D matrix with it. Okay. Then we have this sum region function. In this, we have four parameters: row 1, column 1, which is 0.1, and row 2, column 2, which is 0.2. So we have to return the sum of all the elements present in the region covered by these 2 points. Okay, so we have to return that sum. So now let's go to whiteboard and understand this question better. Okay, so we have to complete these two functions, right? The first function is the constructor function. It will initialize the object with the integer matrix. So let's say we have initialized an object. We have created an instance of our class. So that object, let's say, have this matrix. Okay. Now this function, sum region function, will have four parameters: row 1 and column 1, row 2 and column 2. Okay. This returns the sum of elements of matrix inside the rectangle defined by its upper left corner, that is row 1 and column 1, and lower right corner, or you can say bottom right corner, row 2 and column 2. Okay. What this line means? This line means, let's say we have 2 points. We have 2 points at top left corner, which is, let's say, 1, 1. Okay. And we have a bottom right corner, let's say it is 2, 3. These 2 points are given to us. This function wants us to return what? The sum of all the elements present in the region covered by these 2 points. Okay. What will be the region covered by these 2 points? Go to a first point, draw a vertical line, imaginary vertical line, and draw an imaginary horizontal line. Okay. Go to a second point, draw an imaginary vertical line, and draw an imaginary horizontal line. See an enclosed region here. So this is the region which is covered by these 2 points. Okay. Now, let's say this point is, A comma B. Okay, just generalizing the thing. Let's say this point is A comma B, and let's say this point is C comma D. Okay. Now let us find this point and this point also. Why? Because we will need this point to answer the queries in the future. Okay. I can see that this point have same row as this point and have same column as this point, right? This point have same row as the top left corner, and this point have a same column as the bottom right corner. Okay. So I will simply write its dimension as A because it has same row as this point, and D because it has same column as this point, right? Similarly, using the same logic, this point have the same column as this point and have same row as this point. Okay, so this point will be C comma B. Okay, so if we are given 2 points in this question, in this function, let's say we have 4 parameters. The parameters are A, B, and C, D. We are given 2 points. Then the region enclosed by these 2 points have 4 corners, of course, because the region either will be a rectangle or a square. Okay, it will have 4 corners, and the corner points are, of course, A, B, and C, D are given to us. This point will be A comma D, and this point will be C comma D. Okay, we will use this information in the future. Okay, now let's move forward. Now, let's say we are given 2 points, of course. The first point is 1, 1. The second point is 2, 3. These 2 points are given to us. Now we have to find the sum of all the elements present in a region enclosed by these 2 points, correct? Okay, and I know the region is this. Okay, how will I find the sum of all the elements in this region? Okay, the brute force approach will be by using the nested for loop, a for loop inside the for loop. Okay, how it will work? Let's see. We will create a variable sum. Let's say it is currently 0. Of course, my for loop will start from here. I will pick an element from here. I will add it to my answer. I will pick another element from here. I will add it to my answer. Pick another element from here. Add it to my answer. Now the row will change, right? Pick another element from here. Add it to the answer. Pick another element. Add it to the answer. And pick another element. Add it to the answer. Now my answer is 9, which I will return. Okay. Okay. But I can see I am almost using n into m time complexity here. I'm almost using n into m, where n is the number of rows and m is the number of columns. Okay. Because in worst case, what will happen? In worst case, our first point can be 0, 0, and the second point can be 3, 3. Right? In that case, the region will be this whole matrix. correct? The region will be whole matrix, and I have to cover the whole matrix in order to calculate the sum, right? I have to cover the whole matrix in order to calculate the sum. So the time complexity of worst case will be what? N cross M. Okay, and let's say I have 10 to power 6 queries. I have 10 to power 6 queries. Okay, and one query will take N cross M time, the question will my code will give TLE. My code will give time limit exceeded, right? So I have to reduce the time. I have to somehow reduce this time. Okay. So we have seen in the last question, we can reduce the time in constant time. We can reduce this time N cross M to constant time, right? How? By using prefix sum array. But in this case, we have 2D matrix, so we will calculate a 2D prefix sum. Okay, we will create a 2D prefix sum array. Okay. Okay, so let's see how we can create a 2D prefix sum array. So of course, first of all, we have to create a matrix of same size, right? We have to create a matrix of same size. So 4 cross 4 matrix. So let's say this is our prefix matrix. We will have 4 columns, 1, 2, 3, and 4. We'll have 4 rows, 1, 2, 3, and 4. Right, this is 0, 1, 2, 3, 0, 1, 2, 3. Okay, so this is our prefix matrix. Let's name it prefix. Let's name it original. Okay, let's name this matrix original and let's name this matrix prefix. Now what? Now, let's talk about this matrix first. Let's talk about this prefix matrix first. What I will store here? I will store here the sum of all the elements present in the region covered by point 0, 0 and this point. Okay, so let's say if you are standing on point x comma y, if you are standing on point x comma y, so at that spot you will store the sum of all the elements present in a region covered by points 0, 0 and point x comma y. Okay, okay, so if you are, let's say if you are standing at this point, you will store the sum of all the elements present in this region. If you are standing at this point, you will store all the sum of elements present in this region. Okay, if you are standing on this point, you will store sum of all the elements present in this region. Okay, simple. Okay, so now let's move forward. We will divide this prefix sum matrix into 3 zones. Okay, into 3 zones. This is zone number 1. Okay, this is zone number 2, and this is zone number 3. Okay, 3 zones. Zone number 1 and zone number 2, we will fill the same way we created the prefix sum matrix in the previous question. Okay, because you can see the zone number 1 is a 1D matrix. You can say it is a 1D matrix, right? Zone number 2 is also 1D matrix, because in zone number 1 we have to fill the 0th row. In zone number 2 we have to fill the 0th column, right? So both the 0th row and 0th column will be filled using the same logic which we used in the last video. Okay, and we will talk about zone 3 later. Okay, let's move forward now. So of course, if we are standing here we will fill the sum of all the elements covered by point 0, 0. Sorry, sum of all the elements present in a region covered by point 0, 0 and the point at which we are standing. We are standing at 0, 0. So the region is this. In this region, I only have one element, so I will simply store that element here. Correct? Okay. So we will simply store 1 here. Okay, let's move forward. Let's move forward. Now let's talk about this point. So I am standing at this point. At this point, I have to store the sum of all the elements present in the region covered by point what? 0, 0 and point 0, 1. Okay. So which region I'm talking about here? I am talking about this region, right? Now you can divide this region into 2 parts, right? So this region can be divided into 2 parts, this region and this region. The sum of this region is stored here in the previous box, you can say, and the sum of this region I can take from my original matrix, from my original matrix here, right? Okay. So what I will store here? I will store here, of course, the previous value, which is 1, plus this value, which is 2. So 1 plus 2, it is what? 3. Okay, so I will store here 3. Now let's talk about this point. Here we will store the sum of all the elements present in a region covered by point 0, 0 and this point, which is 0, 2, right? So of course we can divide this region. I am talking about this region, right? So we can divide this region into two regions, this region and this region. The sum of this region is stored here, and the sum of this region is what I can get from my original matrix. Okay. Okay. So what I will store here? I will store here 3, which is the previous value, and this 2. Okay, so 5. I will store here 5. Now, using the same logic, what I will do? Previous value plus this value, right? So I will simply store 6 here. Okay. I will use the same logic to fill this column also. Okay. Previous value, that is this 1 and this 3. So it will be 4. It will be 4. Previous value, that is 4 plus this 5. Previous value, that is 5 and this 2, it will be 7. Okay. So this is how you will fill both the rows, both 0th row and 0th column. Okay. Now let's talk about this zone 3. Let's talk about this zone 3. Okay. So of course I have to fill the values in just constant time. Otherwise, why I'm creating the prefixum array? Okay, then there is no use of prefixum array, right? So I have to fill the values in constant time. How can I fill the values in constant time? By using my neighbors, right? By using my neighbors value. Okay, I have 3 neighbors, this 3, this 1 and this 4, right? Upper neighbor, left neighbor and diagonal neighbor. Okay, if I will store the value of my upper neighbor here, if I will store the value of my upper neighbor here, it means what? It means I have covered this region, because my neighbors stores the sum of all the values present in this region, correct? Okay, so it means I have covered this region. And what region I have to cover? I have to cover, just a second, I have to cover this whole region, right? If I'm standing here, I have to cover this whole region. If I'm standing here, I have to cover this whole region, right? I've already told you. Okay. Now I have to cover this region in order to cover the whole region. Okay. Yes. So how can I cover this region? I know I can use this value also, right? I can use this 4 also. So if I will add 4 here, it means what? It means now I also have covered this region, correct? Okay, but there's a catch. What is the catch? You can see here that I am covering this region twice. I am covering this region twice, once with the upper value and now with the left value, right? So I have to subtract this one once from my answer, right, in order to compensate what I did earlier, right? Okay, so I will subtract 1 from here. Okay, 3 plus 4 minus 1. This means that I have successfully covered this region now. Okay, so now I am only left with this region, which I can cover using this value. I will just go to the original matrix at the same point and I will grab the value from there. Okay, I will simply add this 1 to my answer. Okay, plus 1. Now this is the value I will store here. 3 plus 1 plus 4, sorry, minus 1. So I will store 7 here. Okay, I will store 7 here. Now you can confirm this from here. This is the zone I'm talking about. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 1 is what? 7. Okay, so yeah, we are doing right. Okay, let's move forward. So I'm talking about this point. This point is what? 1, 2. So I have to store the sum of all the elements present in a region covered by point 0, 0 and point 1, 2. It means this region, correct? Okay. Okay. So if I will store the sum, if I store this value 5 here, it means I have covered this region, correct or not? Correct, right? Okay. If I will add this 7, it means now I have also covered this region, correct? Okay. Now you can see what you are covering this region twice. Yes, yes, we are covering this region twice. It means I have to subtract this diagonal value because this 3 stores the sum of all the elements present in this region, which we are covering twice. Okay, so I will subtract this 3 from here. Now it means we have successfully, covered what? We have successfully covered this region. We have successfully covered this region, right? Now we are only left with this region, which I can cover by simply grabbing the value from here. Done. Okay. So what will the value have? 5 plus 7 minus 3 plus this value, which is 2. So this is what? Minus 1. 7 plus 5 is what? 12. 12 minus 1 is 11. Right? 12 minus 1 is 11. Okay. You can confirm that value from here. Right? 2 plus 2, 4 plus 2, 6. 6 plus 3, 9. 9 plus 2 is 11. Okay. Yes, let's move forward. Okay, now similarly, we will use the same formula. You can say 6 plus 11 minus 5. 6 plus 11 minus diagonal value, that is 5, plus the value present at the same position in the original matrix, that is 2. Okay, so this will be 17 minus 5 will be 12 plus 2 will be 14. So this is 14. Okay. This is how you will fill the whole zone 3. Okay. Here 7 plus 5, 12 minus 4 is what? 8 plus 2 is what? 10. So this is 10. You can confirm from here. This is the zone. 1 plus 3 plus 1, 5. 2 plus 1 plus 2, 5. 5 plus 5 is 10. Okay. Yes, let's move forward. Now, of course, same logic. 11 plus 10. 11 plus 10 minus 7 and plus 1. So this is what? 21. And this is what? Minus 6. 21 minus 6 is what? It will be minus 5 will be 16 and minus 1 will be 15. It will be 15. Okay, can confirm from here. This is 5, this is 5, and this is 5, so 15. Right? Okay. Let's move forward. Now, 15 plus 14 minus 11 plus 1. This is what? Minus 10. And this is what? This will be 29 because 15 plus 14 is what? 29. And minus 10 will be 19. So this is 19. Okay. Similarly here, 10 plus 7 minus 5 plus 1. Okay. This is what? 17 minus 5 is what? 12 plus 1 is what? 13. We'll store 13 here. Let's move forward. Here we will store what? 15 plus 13 minus 10 plus 2. Okay. Minus 10 plus 13 is 3. 3 plus 2 is what? 5. 5 plus 15 is what? 20. Okay. Okay. You can confirm that value from here. How? This is what? 5. And this is 5. This is 5. And this is 5. So the whole is what? 20. Okay. Yes. Okay, now let's visualize for the last box. Okay, here we have to store. I'm pointing at, like I'm standing here. The point is what? 3, 3. Here we have to store the sum of all the elements present in a region covered by points 0, 0 and point 3, 3. Okay, so this is the region I'm talking about. Correct? Okay. Now if I will store the value 19 here, the upper value, it means I have covered this region. Okay. If I will store this 20 here, if I will add 20 to my final value, it means I also have covered this region. Correct? Now you can see we are covering this region twice. If I'm covering this region twice, if I will subtract this 15 from my final answer, it will compensate. It will compensate what we are doing wrong here. Correct? Okay, because this 15 stores the sum of all the elements present in this region. Correct? Okay. So 19 plus 20 minus 15 will be what? This will be 5, and 19 plus 5 will be 24. So this 24 is the sum of this region, right? Now I also have to cover this region, which I will simply grab from here. The value of this region I will simply grab from here. Correct? Done. So it will be 24 plus 1, that is 25. Okay. So now we have successfully created our prefix sum array, a 2D prefix sum array. Okay, now we will use this prefix sum array to answer this function, to answer the queries in just constant time. Okay. Okay, let's try to do that. So what we will do here, let's take this prefix sum here and expand it a bit. Now, let's say our first query is, let's say we have 2 points, A comma B and point C comma D, and we have to find the sum of all the elements present in a region covered by these 2 points. Okay, let's say A comma B is here. Let's say A comma B is here, and let's say C comma D is here. Okay. Yes, let's move forward. Now what? This is the region I'm talking about. I'm talking about this region. Correct? Okay, so we have to find the sum of this region. How will I find the sum of this region? Okay, let's try to visualize few things. First, what I will do, I will take a bigger chunk of region. Okay, I will take a bigger chunk of area. Okay, then I will try to trim it down. So let's first take, okay, this is the point A comma B, right? This is the point A comma B. So let me write down A comma B is here. This point is what? C comma D, right? This point is C comma D. And this is the region for which I want to calculate my answer, right? Okay. First, let's take the bigger chunk of the region. First, I will take the value stored here. Okay. So let me create a variable answer. This is my final answer. Let's name it sum. Let's name it sum. So sum is storing the value, this. Sum is storing the value of prefix C comma D. Okay. Prefix C comma D. So this is the bigger chunk of area, right? So what is the area here? What is the area which we have covered? We have covered, let me first mark the points. This is A comma B and this is C comma D, right? So we have covered this region. We have covered this whole region, right? Because this 25 is the sum of all the elements present in this whole region, right? Okay, so we have covered this whole region. Now, I only want the sum of elements present in this region. Correct? Okay. So what I can do here, I can trim down my bigger chunk of area, okay, by removing this region from it. Okay. If I will remove this region from it, I will only left with what? I will only left with this region. I will only left with this region. Correct? Okay. How can I remove this region from my bigger chunk of region? By simply subtracting this value, because this 14 store the sum of all the elements present in this region. Correct or not? Okay. So what is this? Like, how can I get this value? How can I get this value? Okay, let's see. I know this point is what? We can look at this diagram. If this point is A comma B and this point is what? C comma D. So this point is what? A comma D, and this point is what? It's C comma B. Okay. I told you we will use this information later, right? So now is the time. Okay. So if this point is A comma D, this point is C comma D, this point is A comma B, and this point is C comma B. So this point will be A minus 1 comma D, because if this is Ath row, this will be A minus 1th row, correct or not? Okay, so this point will be A minus 1 comma D. So in order to remove this region from my bigger chunk of region, I have to just write one thing, that is minus prefix of what? A minus 1 comma D, correct or not? Okay, let's move forward. Now we are left with what region? We are left with this region. Okay, this green region. But we want only the sum of this red region, right? It means I have to trim down this region, correct or not? Correct. Okay. So I have to subtract the sum of this region. How will I get the sum of this region? Simple. This whole region, right? This whole region, subtract this region, will give me this region, which I required. Okay. What is this whole region? What is the sum of this whole region? It is stored here. What is this point? If this point is a C comma B, then this point will be C comma B minus 1, one column to its left. If this point is C comma B, then this point will be C comma B minus 1. Okay. So the sum of this whole region will be stored at point prefix C B minus 1, correct? Okay. Now from the whole region, I have to subtract out what region? This region, right? I have to subtract out this region. So the sum of this region is present here. And what is this point? If this point is A comma B, then this point will be what? A minus 1 comma B minus 1. Okay, correct or not? If this point is A minus 1 comma B minus 1, I can simply get the sum of this region by what? By this value, prefix of what? A minus 1 comma B minus 1. Okay. If I will subtract this value from this value, if I will do this, I will simply get this region, the region I required. Okay. Okay, let me write it down clearly here. Okay, so the sum of this region is this prefix of C comma B minus 1, that is this whole region, and subtract prefix of A minus B comma B minus 1, that is this region. Subtracting this region will give us this region, which is the region we required. Okay. So now, if one more thing, this value, this sum value is the sum of all the elements present in this region, this whole region. If I will subtract this value from this value, I will get the sum of my red region. Okay. Okay. So let's subtract this from this. So if you will subtract this value from this, you will get what? Prefix of C comma B minus 1, and this is already in negative, so will negative will become positive. It will become plus prefix of A minus 1 comma B minus 1. So this is your final answer. This formula will give you the sum of all the elements present in a region covered by points A comma B and C comma D. Okay. In constant time, of course, in constant time. So I hope you guys understood the explanation.